This web application was built using the Django web framework. The primary purpose of this website is to host the download function for desktop software. I tried to convey the concepts of the project throughout the design of the website while explaining the different techniques and different aspects that I use to perform activity recognition. I provide the download functionality using the button inside labeled download. I also provide a description of who I am and what my goals are with the project. In the research section, each specific technique that I utilize to craft the project is shown here. Each technique provides a link to more information on the topic. Symbolic approximation relates to the technique used in converting a time series to an activity string of characters which encode the time series. The bitmap generation is then explained in relation to how we convert each windowed activity string into an image. Each image can then be fed into our convolutional neural network, which is built on top of Google's Inception v3 model using transfer learning. We also use MQTT, which is a publish-subscribe model, to communicate among clients and servers. A client can be considered a user executing our desktop software. We are using a thin client fat server architecture for this. Now, I also maintain a blog on this website to track all the progress I've made over the project's duration. Each blog entry here represents a different update to the project while discussing where the project is going next. I also provide comprehensive detail as well as images to describe the processes that I undertook and the processes that the project used to craft it. So I think there's over 30 blog entries here which describe the whole process that I went through. And then finally, the discussion section. I also provide a discussion section for other users to discuss the project and activity recognition in general. This section is enabled through using Postgres SQL as the backend database to store usernames, comments, dates, and times. So take your Arduino device, equip it to your machine. The Arduino should light up in correspondence with that connection. And then take your PPG wrist mounted device and equip it to your wrist. Equip it tightly enough so that your heart rate can be accurately measured. So this is the primary screen, and you can see that the Arduino PPG connected has now connected because I just plugged it in. The settings offers you to choose a different port depending on if the Arduino is connected differently on your machine. This is the about the application screen, so just a bit of information about how I created things. There's an exit button. This is also the port selection again, and there's also an application guide where you can learn how to use the application if you don't understand. This is the main screen split into 4 windows, and this is a different view. This is the activity recognition view, this is the real-time graph view, and then this is the research view, where you can tell and learn more about the application overall. This is one of the primary functions I'm about to show you. It's called the activity recognition playback function. And you can submit a past PPG recording file in the form of a CSV, and it should play back in real time what activity was being done. So you can see here that, for example, it thinks it's fast cycle and now it thinks it's walk. It also gives you the exercise time as well as the accuracy of that prediction. And also I have a little Mario avatar as well to display the activity. The graph on the right hand side also shows the microvolt recordings. Yeah, so there's the graph. And if you want to zoom into the graph, hopefully you can click on the real-time graph view like this and you can see the graph in its purest form. So outside of that, we also have a recording mode whereby you can connect a PPG device via an Arduino, equip it to your wrist, and then actively record and monitor the PPG signals that come from it. So for example, this recording you see in the graph is being recorded into a file on your machine called voltages01.csv. It's saved in your documents or downloads or somewhere like that. Probably downloads, I believe. And you can then analyze that and then probably resubmit it back into the activity playback function, which is quite cool.